You're putting Pedro on it?
All right, so with the last part of chapter 15, we've got to cover 15.4, 15.5, and 15.6. So now we're actually going to do actual probability. So if you have a bag full of marbles, what's the probability of pulling out a green? Okay, so we're actually going to do fractions and probability here. The first thing we need to talk about, though, is probability spaces. What do you get to pick from? Okay, so something like probability of rolling a 1 on a die. Your probability space would be all of the options you have on a die. So your numbers 1 through 6. Okay, so we've got different types of events that can happen. The first one is called a simple event. And this is an event with one outcome. Okay, so something like you roll a die. What's the probability of rolling a 1?
1 out of 6.
That's a simple event. We have something called an impossible event. What do you think that means?
There's no answer?
There's no outcome. Okay? An event with no outcome. So, something like, what's the probability of rolling a 7 on a die?
0 out of 6.
Okay, 0 out of 6. It'll never happen.
Unless you got a 7. Or don't make it Norman got one.
What is that called?
Okay, can we just deal with normal
7-sided
die
die.
here, please? I understand that there's like 20-sided die and all of that happy stuff. Okay. Certain event.
It's like,
It's going to happen?
yeah.
It's going to happen. Okay. This is an event with all outcomes. So something like, what's the probability of rolling a number less than 7 on a die? 100%. All of the numbers on a die are less than 7. Okay. Question. Okay. So let's pull out events given the sample spaces. So we have tossed a coin 3 different times. Okay. Your sample space is all of the options that you have. We can get 3 heads in a row. We can get a tails and then 2 heads. We can get heads, tails, heads, 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 tails, so on and so forth. Those are all of your options. Your events are little pieces of these options. So looking at the options we have, which ones fall under the category toss 2 or more heads?
HHH.
HHH falls into that category.
THH.
THH.
HTH.
HTH.
HHT.
HHT. Anything else?
No.
No. If I asked you what the probability of this was, what would you tell me? What's the probability that this event will happen?
4 out of 8.
4 out of 8. I've got 8 total options, which means this is 4 out of 8, which reduces to 1 head.
It's still like this. But,
What falls into toss more than 2 heads? HHH.
that's it.
That's it. Okay. What falls under the category toss 2 or less heads? DHH. HTH. Everything but the triple H. Okay.
Legs. Jeff Wells.
DTH, THT, HTT, and TTT. Okay.
What does TTT?
It's 2 or less.
2 or less heads. It has no heads in it, so that's less than 2. Tossing no heads. TTT. is the only one that falls into that category. What about tossing exactly one tail?
H, HHT, and HCH.
DHH, you said HTH
I mean, ooh,
and HHT.
yeah.
No, you were right. Okay. What about where the first toss is, I'm sorry, heads. First toss is heads. HHH, HTH, HHT, and HTT. What about the same number of heads as tails? That'll never happen. This is your impossible event. And what about tossing 3 heads or less? That's all of them. So we call this certain. Because everything from the sample space is used.
He wants HCH.
They're so coding.
Questions? Okay, this next one. We're tossing a coin and rolling a die. The first thing I need to do, though, is create my sample space. I didn't give it to you this time. So what does my sample space look like here?
Heads.
Heads.
Tails.
One.
I'm tossing a coin and then rolling a die. So heads.
Oh man, we gotta
Heads 1.
Or
What else?
Heads.
Heads 2.
Heads all the way through 6.
All the way through 6.
And vice versa with tail.
Okay, and the same thing for tails. Tails 1 through 6.
Can I take this? Please?
No. The first event I want to look at is an even number. What falls under the category of an even number?
H2,
H2,
H4, H6,
H4, H6,
T2, T4, T.
T2, T4, T6. Event 2 is head.
H1 through 6.
H1 through 6. I'm going to shorthand it and literally write H1 through 6.
That's what I was gonna do.
Okay. So H1, H2, H3, H4, H5, H6. A head and an odd number.
H1, H3.
H1, H3, H5. What about a tail and a prime number?
T1,
T3.
T2,
3,
Everything except 4 and 6.
everything except 4 and 6. What about a number that's less than 7?
all of them.
All of them.
Certain.
So this is certain. What about a number that's less than 3?
H1,
H1 and H2,
T1,
and T1 and T2.
possible.
And finally, for the last one, a 7 is rolled. That's impossible. It's never going to happen. Here comes the hard part. Okay, so probability assignments. Okay, if it is an impossible event, your probability is 0. It's never going to happen. If it is a certain event, your probability is 1. Okay, 1 represents 100%. It's just in decimal form. Okay, anything else is in between 0 and 1. So you're always going to either have a fraction or a decimal between the numbers 0 and 1. Probability can never ever be negative. Okay. The most important thing that you're going to need to know right now is this line right here. I don't care what you need to do with it. Highlight it, circle it, whatever. The sum of your probabilities of all of your simple events has to equal 1. Okay, so what I mean by that, looking at a die, what's the probability of a 1?
1/6.
1/6. A 2.
1/6.
A 3. Okay, we've gotten to the point where they're all 1/6, correct?
Yeah.
Each little simple event. If I add them all up,
Get 1.
you get 1. Okay, it works every time. So all of the pieces added together should always equal 1. With that being said, that leads us here. Okay, we've got 6 players in a tennis tournament. Anna is Russian female, Ivan is Croatian male, Leighton is Aussie male, Roger is Swiss male, Serena is American female, and Venus is American female. Your sample space is who could win the tournament. Who's able to win the tournament? Anyone. Any of them. So your sample space is Anna, Ivan, Leighton, Roger, Serena, and Venus. So that means each individual one of these is a simple event. Okay, the probability that Anna's going to win is a simple event. Okay, so if I add all of these together, it should equal 1. So below that, it gives you all of the odds of each person winning. Anna has an 800th chance of winning. Ivan, 1600, so on and so forth. The only person they don't give us is Serena. How am I going to find Serena's
Add them all
probability?
together, subtract them from 1.
Add them all together and subtract them from 1. So you're going to add 0.08, 0.16, 0.20, 0.25, and 0.16. It's not either one of those. Point what? 0.85.
0.15.
Okay, so if all of these added together is 0.85, that means Serena has 0.15. Question. Pretty simple, right?
Yes.
Sure, you guess? Fantastic. Okay. Aw, how sweet is she?
Nicer than Brenda.
Nicer than Brenda? I don't know anybody that's nicer than Brenda.
No.
Okay. Probability represents the probability of simple events and all other probabilities followed by addition. So I can find the probability that an American will win. The first thing I need to do is identify who's American.
Venus and Serena.
Venus and Serena. So I need to find the probabilities of Venus and Serena. What was the probability of Venus? 0.16. What's the probability of Serena?
0.39.
So that means 0.31 chance of an American win.
That's it.
You can leave it as 0.31.
How do you know to do the decimal instead of just doing 2 out of 6?
Because here they gave it to you as a decimal. So you're gonna stick with decimal. What's the probability that you're gonna have a male win?
Because Ivan is Leighton and God.
Yes.
Alright.
Ivan,
Roger.
Leighton, and Roger. So Ivan's probability is
2016,
0.16,
2020,
0.20,
and then 2012.
and 0.25. And 0.61. I will tell you on your test for this whether it needs to be in a fraction of form or not. Also remember your final exam's multiple choice. So if they want it in decimal form, they're going to give you decimal choices. What about the probability of an American male winning?
0.
0.
Impossible.
It's an impossible event. There's no American males competing. There's American females, but no American males. What is the probability of a European winning?
Swiss European.
Which is European? Is Croatia European though?
Croatian is European, so that's Ivan.
Everyone
How
from,
do they
except for
expect
the
us to-
Americans.
And you said Swiss, yes. He's also considering, and Third Block argued with me,
Russia's not European.
he's also considering Anna.
Russia
No,
is European.
But
Russia's
Baden's telling me that Russia's not European.
Russia
so-
is the two
Russia.
continents. Russia's
Right.
part of two continents. It's European and it's also Middle Eastern.
Not bad.
Russia is its own continent.
Right.
Corrupt the network, wait. Right.
So,
About Russia.
All right, let's not count Anna.
okay.
How about we don't do race?
Okay. Let's not count Anna. So, Ivan has a probability of
16.
16, and Roger 0.25, which gives us 41.
0.41. Thank you. I didn't know that.
Finally, the last one. What's the probability that a female will win?
Anna
Anna,
Serena, and Venus.
Venus,
Venus is a boy, isn't it? No.
No, it's you've never heard of Venus and Serena Williams, the tennis players?
I do. I
Both
know who they are.
the biggest. Big.
So 0.08, 0.16, and 0.15 for a grand total of 0.39. Okay. There was another way that you could have come up with this last one without adding together all the females.
Take
What's
31.
opposite of female?
Male?
Male. We already found the probability of being a male, right?
Right.
Which was what?
61.
61. So 1 whole minus being a male means that you're a female. Okay. And we're actually going to talk about this a little later. This is called the complement. Okay. It's opposite. If you're not male, you're female.
Either non-binary.
What?
Did you just assume their gender?
Okay. And again, this just reiterates the fact that impossible means you have 0 probability. If it's certain, you have 1. And if it's anything in between, it should be a decimal.
Not symbols.
Okay. So let's finish up this section with this.
No, we're done.
So we're going to start 15.5. We're not going to finish it. We don't have much left to do. Consider the sample space. Sigma 1, Sigma 2, Sigma 3, and Sigma 4. Okay? Don't get confused because they're using Greek letters. We can make that X1, X2, X3, and X4. I don't care. Okay? They just use a lot of Greek symbols in math, and that is sigma. Okay?
Beta Sigma Delta.
So, if I have 4 sample space, 4 things in my sample space, and all outcomes are equally likely, what are their probabilities?
25.
If all outcomes are equally likely, 20.25.
0.25. Okay? 0.25. Remember, if I add all 3 of these together, so if I add sigma 1 plus sigma 2 plus sigma 3 plus sigma 4, and that equals 1,
Okay.
and they're all the same. Think about 1 as $1.
Right.
Okay, so that makes each one of these worth a quarter.
I'm just doing X's.
Okay, we can do these X's. Watch. What happened? So, if probability of sigma 1 is 0.3, the probability of sigma 2 is 0.25, and the probability of sigma 3 is 0.17, then what is the probability of sigma 4? So, this is my unknown. I'm going to make it an X. And we said all of the probabilities altogether should equal 1. So, 0.3 plus 0.25 for event 2 plus 0.17 for event 3 plus X should equal 1. Okay, this does the same thing that we did where Andy said add them all together and subtract from 1. Okay, this does the same thing, it's just an equation form. So, we're going to add all these together, and that gives me what? What? How does this plus this plus this equal that? Where are you getting 0.17?
I said 0.72.
Oh, I could have sworn you said 17, and I'm like, where are you coming up with 17? Oh my.
Right.
Apparently I have drool in my ear. 0.72 plus X equals 1. How do I now get X by itself? Subtract 0.72. So what do I get when I subtract 0.72? 0.28. So the ones that you don't know, you need to create variables for them so you can plug them into the equations. So part C gives you the probability of event 1 is 0.18, event 2 is 0.12, and then they tell you that 3 is equal to 4. So we need to create a variable. Let's use X. So we're going to make 3X. What does that mean 4 is?
X.
X. If 3 equals 4, then 4 is also X. So now we have 1 plus event 2 plus event 3 plus event 4 equals 1. Combine like terms and solve. 0.3.
So
0.3 plus, what's X and X?
2X.
2X equals 1. Now what?
Subtract 0.3.
Subtract 0.3.
0.7.
2X equals 0.7.
Divide.
Divided by 2. X equals 0.35. Am I finished?
No, we gotta find 4.
They're the same thing.
Oh, shoot.
4 is X. So yes, we are finished here. Okay. Yes.
Next one's hard.
Alright, let's see.
Oh, God.
Let me get through these two. Okay, D says event 1 is 0.18, event 2 is 0.22, and 3 is double 4. So, what can we use if 3 is double 4?
2X.
Okay,
And X.
2x is what?
2X is 3.
2x is event 3. And 4 is just x. Okay. Can't even remember what chapter it was. Remember when I told you to assign your lowest one, its variable first, and then go from there?
Kind of.
Okay. I don't remember what chapter it was, to be honest with you. So, event 3 is double event 4. So, which one's my lowest one? 3 or 4?
Event 4.
Event 4. So, you would assign that x. Then go back from there and assign, if 3 is double that, it means it's 2 times it. So now we've got event 1 and event 2 plus event 3 plus event 4 equals 1. So when I combine like terms, I get
0.3.
mm-mm,
No. Oh, it's
Give 0.4
0.4
plus
x equals 0.6, x equals 0.2.
you gotta multiply.
Are we done?
No, you gotta multiply that by 2.
What's it asking? It's only asking what 4 is.
Oh.
Well, 4 is x. So guess what?
We done.
You done.
Right.
If it asked you what 3 was, yes, you would have to go back and you would have to multiply it by 2. Okay? Last one in the section. If 1 is double and 2 equals 3, which equals 4, what are all of the probabilities? So again,
87.
you want to find the one with the least probability, which is going to be event what?
No.
2. Okay, so assign that a variable. So if 2 is x, what does that make 1?
2x.
2x. It's double it. What does that make 3?
X.
X, and 4 is
X.
x. So 2x plus x plus x plus x equals 1.
I'll melt down if I saw this one too.
I guarantee you're going to see this again.
Melt down.
You erase all that and do it again? Like, for real.
Guarantee you're going to see this again. So when I combine like terms, my left-hand side looks like what?
5x.
5x equals 1. Divide by 5.
Wow.
So x equals
1/5.
1/5. Give it to me as a decimal since everything else is in decimals. 0.2. Okay. It's asking though, what are all of the probabilities? So you need to go back and tell me sigma 1 is 0.4. Because remember, it's 2 times x. What is sigma 2? 0.2. What is sigma 3? And what is sigma 4? And a good way to check yourself, add them all up, and if they equal 1, you should be good to go. Go potty. We're gonna do the back side of that, and we may just stop there for today.
I'm trash and no. At all.
Yeah.
Look,
Give it a minute or two for Saphir to come back.
so when it's moving, yeah, you reckon?
You're not gonna be here, what?
Oh,
Huh?
I'm not gonna be on it. It's Saturday.
Where you going?
One in my uncle's house. Celebrate my birthday down there. I'm getting my tattoo done. One day is more than one. Wow. I'm like, oh, man. Right. I think I was doing it Friday, Saturday. Just let me know. I'm in. I'm coming to a left.
Okay, equal probable spaces. Okay, so here's where we actually find the actual ratios, fraction form of probability. Remember, when we're finding probability, the number that goes in the bottom is how many total options you have. Okay, so you've got 2 sides on a coin, so the bottom number would be a 2. You've got 6 sides on a die, your bottom number would be 6. Okay, the number that goes in the top is the event that you're trying to find. So if you're finding the even numbers on a die, you've got 3 even numbers, so your top number is 3, so on and so forth. So example number 1, 12 boys, 15 girls in a class. What's the probability that a boy will be called out of the class? Okay. 12 out of 27. I've got 12 boys in the class and a total of 27 students. What's the probability of rolling a 1 on a die? 1 out of 6. There's only one number, 1 on a die. What's the probability of rolling an even number?
1/2.
1/2, because it's actually 3 out of 6, which reduces down. Okay. What? A 4-character password is being made from numbers and letters, which are not case sensitive. Okay. So, how many options do I have to fill in each slot of my 4-digit or my 4-character password? 36. I've got 26 letters and 10 numbers. So that means my bottom of my fraction is 36. How many spaces am I filling in with a letter or a number? 4. So my bottom number is 36 to the 4th. Okay? 36 to the 4th. I haven't even gotten into what they want me to do yet. This is just my total amount that I have. 36 to the 4th. Okay? So now, to do the top, what is the probability of a password being all numbers? 10 to the 4th. I've got 10 digits, and I'm filling 4 spaces with them. If you plug this into your calculator, it comes out to be 0.00595. Okay, this next one, we still haven't changed the password, so that means my bottom number hasn't changed. It's 36 to the 4th. My top number now, though, says, what is the probability of a password beginning with 2 letters and 2 numbers? 26 to the 2, that represents your letters, times 10 squared to represent your numbers. I was so used to him saying to the 2 that I just picked up on it.
Amy Smith.
Oh.
So, today, 7.
These are
We're on D6.
It should never be a number bigger than 1. Yes. You raised the 36 to the second, not to the fourth. So you should have gotten 0.04025. Okay. The last thing I want to talk about today is compliments. We're gonna finish this page.
I like your compliment.
I like your shirt.
Hey, Miss Smith.
I wish that's what we were talking about. You could just, butter me up like Mr. Smith over there, Miss Smith is the best teacher ever.
I thought you were talking about like a
Riley is so adorable.
Right.
I can't believe that nigga really.
I can't believe Blue said that she recorded.
Huh?
But so that means we have 4 days of review.
What do you mean we have 4 days of review?
Today is 7, so tomorrow be 6. Thursday be 5.
So yeah, we'll have all 4 days after Memorial Day for review.
Are we out of school more?
Yes.
When is that?
This weekend. So you guys have your senior trip Friday and then you're off Saturday, Sunday, Monday.
I'm in there
That's the
Friday.
best part.
Heard.
Right, we all out of school.
Right.
Okay, so what a compliment means in math is not the event. It's the opposite of what you see. So if my event is picking a black card, what is the compliment? Okay, so your compliment is technically not a black,
Wow. You say that?
which is AKA a red card.
So that's diamonds. Right.
My event is picking a heart.
Black.
So this is not a heart, which is what?
It'd be like the club,
A club,
diamond.
diamond, and a spade.
That's it.
Okay? A lot of you read too much into it when you think compliment. It's not quite as hard as you think. So, picking a heart means you're not a heart, which means you're a club, a diamond, or a spade.
What?
Okay. 3. Your event is a 4-question true or false test with at most 2 true. What does the words at most 2 true mean?
Yeah, there's no more than 2.
There's no more than 2. Okay? So if there's no more than 2, what is my complement?
1, 2, more than
2
2
false ones.
2, yeah.
More than 2.
Okay? More than 2.
I don't like that.
Okay? If you need to spell it out, at most 2 means we have none, 1, or 2, correct? That's the event. This is the event. So then not the event would be 3 or 4, which is more than 2. Or you can also write this as at least 3. So if you need to write the event down first and then write what is different than the event, by all means do so. Does that make sense?
Mm-hmm.
Why do I stop at 4?
Because there's
It's
only
a
4
4 question
It's a 4-question test. So keep that in mind as well. Event. You flip a coin twice and get 1 tail. 2 tails is opposite. What else is opposite? There's one more.
Flip it once.
2 tail or no, can't change the flip.
Or 2 heads.
2 tails.
2 heads.
Don't
Head.
switch from the topic at hand.
Head tail, like.
So we can either get 2 tails,
3 tails.
1 tail,
No tail.
No tails.
I like that.
Okay. If you need to with this one, think about it. You're flipping a coin twice, so I can get heads, 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 tails, tails, heads, or tails, tails. So getting one head, erase, or one tail, erase those. So then take a look at your options. This one has no tails. This one has two.
So we couldn't say two heads.
No.
Okay.
They're talking tails. You want to stick strictly with tails. Okay. Event. Flipping a coin 3 times and getting all heads.
3T.
Again, we're talking
Oh.
heads. Keep it in heads.
Heads, heads,
Two
heads.
heads.
Okay, so all heads would mean we have how many?
3.
3. So I can have 2 heads, 1 head,
No head.
No.
and none.
No head.
Everybody forgets about the fact that you can have none, where you have all tails. Okay. Number 6. Roll a die 6 times and get at least 4 even digits. What does the word at least 4 mean?
4 is the highest.
Lowest.
Oh,
1 through
4 is the lowest.
Let me get 100.
So this means my event is 4, 5, and 6. So what is not the event?
3, 2, 1, 0.
Perfect.
Woo, woo.
At least 4 means 4 or more. So your event is 4, 5, and 6.
How can you get 0 on
How
that?
can you get 0?
I can get 0 even numbers. I could land on an odd. It's not talking about what number you're landing on. It's how, we're talking about even digits. You can land on a digit that's not even. Now that said some number between 1 and 6, yeah, that would not make any sense. Yeah. Think even. Okay.
So what's the
Questions?
What's the answer?
3, 2, 1, or 0.
That's
Even
even
numbers. That's the complement. Yes.
Yeah.
It's opposite of what they're asking. You could also have said, instead of doing 3, 2, and 1, you could have called this
Cold, cold, and cold.
at most 3. That's what this means. Okay. So you could have also called that at most 3. Questions?
Alright.